Bob Mimlitz here at Vex Worlds talking to teams about how they engineered their robot. I heard a story that their robot didn't look like this at the beginning of the competition. Why does it look different?
So we started our journey in robotics last year, and it started as a clawbot.
You have a robot and it works. Why did you get rid of the claw and switch to this 4-bar linkage?
The claw just wasn't grabbing on how we needed it to, because we wanted to be able to stack on top of the balance.
Now there's another mechanism on the back of your robot.
That's a tail. We had balance issues at first on this arm.
So when you picked up a goal,
mobile goal, yeah.
It what, tipped forward?
Tipped forward, yeah.
Okay.
And so we added this to clamp down on a second host, so then it acts as a counterbalance.
Oh, so you grab another goal back here just so you can lift this one up?
Yeah.
Well, that's cool.
Because this year's game had so many objects and ways to maneuver them, we knew that we had to get it up high somehow. So we thought about like different ideas, like a linear slider. But like after looking at different designs from different teams, we landed on a 4-bar lift. Because you have 4 bars here, when you move it up, the claw will stay straight up. So when you're lifting a goal, it's going to be straight and no rings are going to fall out.
We like to make our autonomous programs really reliable, especially in this game where we have that portion of the field that teams can interact in.
Right.
So we want to make our autonomous programs reliable.
Reliable, right. What's your favorite sensor?
My personal favorite is the vision sensor. So what we do is we detect the color. In this case, we would detect yellow. And what we do is we find the X coordinate of that goal relative to where the sensor is. And then we adjust the powers of our drivetrain based on that to go and find it.
Wow, that's amazing. This robot has a really cool mechanism to drive parts of the robot without even using a motor. How in the world does that work?
So how it works is that our intake is actually connected to our 2 front motors. And so whenever we want to drive forward, both motors work together to move the whole intake.
So you went through a lot of complexity just to save a motor.
Yes.
Why did you spend all that time to save one motor?
We stick out at these tournaments. Like with this claw, we want to have a huge claw, and like it's like why it's called fluffy. It's like almost like a hugger. It just grabs
A big
you.
hug, okay.
Yeah. It's Worlds, so we should be able to like do something different.
How did you know how to build this?
Well, at first we didn't. At competitions, we looked at other people's bots and we observed them, looked at how they did their things, asked them questions.
So you did research,
Yeah, we did.
and you learned from other teams, which is great. You always learn from other people.
The thing about this game is there were 2 main ways to score things. We have rings and we have goals. The first stage of our intake is this big wall you see here with all these flaps and all this chain. And that will bring these rings that are scattered all across the field into this little bucket system we have in the middle, but that basically stores all the rings and funnels them into one area and puts it into this Pringles can that we have on the other side of the robot.
This is an incredible robot, guys. It takes a long time to integrate all this together. You didn't just start building this and then you were done. Thank you all very much for your time, and I hope you guys learned something about building incredible robots.